There we go. All right. I used to run conferences, and I always loved it when speakers changed their talk title right before the talk. So had to make sure that I put that in there. Yeah, I've been doing, I guess, this a while, open source web stuff. Did a lot of node stuff and things. But for the last 4 years or so, I've been working pretty much full time on decentralizing the web. I gave a talk at the last in-person Cascadia about that, and it was really about some things that we had just maybe figured out that you could maybe do. And now there's real things that I can show you that we're doing. So that's really exciting. So about 1.5 years ago, the team that I lead started this project called NFT.storage. NFTs are really expensive gifts, and they are on a blockchain, but not on a blockchain, actually. It turns out that the transaction is on a blockchain, and the thing that you trade that costs a lot of money is on a blockchain, but the actual art that people care about actually receiving is not on the blockchain, and could just be in some random person's server that they change. And in in the decentralized web, we have this thing called IPFS, and it literally solves that problem. And we were like, hey, everybody in the NFT ecosystem, you should really use IPFS to solve that. And they were like, I got to run what now? So we figured out how to host everybody's NFT assets. And that meant scaling the IPFS protocols, writing new implementations, but it also, in a really good way, put me and my team face-to-face with a lot of real end users. And the NFT ecosystem is actually rad. Don't pay attention to Twitter. The NFT ecosystem is just people that create things. It's a lot of artists. It's a lot of people that like to make stuff and like to put it out there. It's actually, in a lot of ways, reminds me of the early web community, like Rachel was talking about yesterday. It's actually very cool. And the more that we started listening to these users, and the closer that we got to their use cases, the more that it kind of showed us what we needed to improve in IPFS and what we needed to improve as a service provider to really bridge the next gap to really make Web3 applications happen and to make a decentralized web happen. And a decentralized web that is not just put my thing on a blockchain. So we created this thing called Web3.storage, which is really the platform that we wished that we had when we wrote NFT.storage. Basically. It is an at-scale cloud-native IPFS host that does a lot of really good stuff, and all your data comes out of a CDN and all of that. And to really show the value of what I'm talking about, you have to rethink what the web means a little bit. Because I've been in the, I've been in the web for 20 years, and I don't know what that means. It means something a little bit different to everybody. And Tim Berners-Lee may disagree with me. But it is made of protocols. That's definitely true. Everything that we do is some kind of open standard, it's some kind of open protocol. And the thing that makes it a web is this interlinking that happens between all of those protocols. It's what allows people to be compatible with each other. It's really it's like the material that we all stand on. It's the ground that we stand on. And if you want to improve the web, if you want to decentralize the web, you really need to think in terms of protocols, not in terms of projects. It's not an open source project, it's not a framework, it's not a language, it's definitely not a blockchain. It is a set of protocols that connect all of those things together. Regardless of how you feel about blockchains, it needs to connect them as well, and it also needs to connect all the things that are not blockchains. For the most part, on the web today, we use location addresses, URIs, and they're amazing. The moment that you don't have them, you're like, why am I doing? You're in some native application, and you're like, you want to show somebody a view, and you just don't have an URL, and you're like, God, this sucks. Why is it? It happens all the time, right? But when you're on the web, when you're a web developer, you really love URLs. You love links. They really do their job well. And now that we have all these great tools for building static assets, you start to see how all of these links and these HTTP addresses cache really well as well. And so they are really wonderful. The thing that sucks about them is that they are location addresses. So if you start addressing things with location addresses, you put those things into a location, which is also a word for centralization, right? And what we're talking about is decentralization, right? What we're talking about is a bunch of actors with a bunch of data, and we've also got a bunch of actors with data, right? We have individual people, and they are not stuck in one single place. We have a lot of our data that we need to take with us, that we need to transport from one service to another, that we need to back up. And then, of course, we have a million actors who, right now they have all of our data, which sucks. But they will have some of our data at some point that they need to operate on, right? And all of these actors and data right now are all addressed with locations, which means that all of it is centralized and all of it has to be handed to individual actors that can't really integrate very well with each other. And what we want to do is provide a means of decentralization. Now, where do I start with this, man? This word, man, it doesn't mean anything. It means whatever you want it to mean, really, which is definitely true if you go to a conference. It doesn't mean, some wild transport, right? That's really what peer-to-peer means to people. And when you talk about peer-to-peer, you talk about, BitTorrent or even a lot of blockchains. When people talk about them, they talk about this network of all these different people putting things to each other and how the data moves between some fancy transport. And that doesn't describe any kind of user value, right? I've been here a long time. Never had a developer say, I really want to just run all my own servers. It's awesome. I want to run lots of nodes that do things. Never had a user say, I would just love to run another process all the time that's just doing something on my phone. Yeah, that's the thing that you hear all the time. But that's kind of the model that you're into when you talk about decentralization, when you look at it from a network perspective, when you think about these actors and what they do, and you're really focused on the location of where something is at. What we really need to do is take all of the things, all of the actual individual artifacts in our stack, and think about them independently and figure out how to transport them. Figure out how to decentralize each of these independent pieces so that it doesn't matter what the transport layer is, it doesn't matter where the data is, we can just move it around. It's optimal portability, effectively. So that's my little rant. So we have addresses for data, one of our problems. This is the IPFS addressing format. It's called the CID. Brooklyn talked about it a bit already, so I don't really need to get into it. All the blocks and addresses in her talk are awesome IPFS blocks and addresses. It's great. Something that's not really well appreciated about this particular protocol standard is that it's not just a hash. It's actually a hash that tells you what kind of hash that it is. So it's every current and future content validation function. Because just like any other addressing standard, that's just a bit, and we have literally infinite numbers. I don't know if you know that. That's how versions work and how numbers work. There's a lot of them. And we have varants, and so they get real big. And we can just use a different variant to describe different types of data. So this one addressing format can address blocks from Bitcoin, blocks from Ethereum, blocks from Git, blocks from BitTorrent, blocks in IPFS, blocks in numerous current and future standards. And that's really important because every blockchain wants to invent their own block format. It's really, they love it. They just love shaving those bytes. We also now have actor addressing. The DID standard finally passed out of the W3C. It is very, very good at describing these subjects that are persons, organizations, identities. It's very good at describing things that you can call that you can basically swap in a public key for. Like many addressing formats, it has a whole layer underneath it that can do a million other things that I'm skeptical of. I don't think that will work. But for addressing public key actors, it's beautiful and really, really nice. And the other stuff, it might be cool. I've been wrong. There's audio of me on a podcast saying that I will never, under any circumstances, use promises. And Asake Awake came out, and I was like, this is fucking dope. I do this all the time. So yeah, you can decentralize this. You can actually decentralize actors and data now. Or as I should put it, you can decentralize this. Yay puns, and yeah, you can puns. So you can is basically decentralized OAuth. You can kind of think about it that way. It definitely fits into your stack, but it is a little bit more, and there's a way in which this kind of undersells it a little bit. And I didn't write this. We didn't write this. Brooklyn made this, actually. So that's how badass Brooklyn is. She talked, and then I'm going to talk about another thing that she made. So UCAN is just like a very different way to think about permissioning, right? Because there is no centralized actor. There's no coordinator. It's not like OAuth in that way. You describe the capability that you want someone to have in data. You say this person can write, this person can read, whatever that they need to do on some object, and then you hand that to another actor, right? So any right that you can express in the data can be granted to anyone. There's no limitation on kind of what you can express, right? And because any right described in data that is addressed by hash can be delivered to any actor, that means that any of these rights can be sent to any addressable location. This isn't like bearer tokens where you have to keep them private. You can literally hand them to anybody and you can move them over any transport. And it's also not something that you even need to map into HTTP necessarily. Like you can pass these, they're literally proof chains, like literally proof chains in blocks that you can pass around in IPFS or move in and out of blockchains, in and out of like every network that you'd ever want. And you can also describe them in JWTs and integrate them with your JWT infrastructure that you already have. They're really flexible that way. Another like very, very, very important thing that UCAN very much got right was that UCAN allows you to delegate any permission. There's just it doesn't allow you to not delegate. And that's very important. If you've ever dealt and tried to build public key cryptography systems, you'll understand that the moment that you can't describe the delegation in the system that you're working in, you now have to front that entire system with something that's managing that key. And the longer that you use that key for something, it's just a liability. It's just going to go away. And you can't like get the delegation into the thing that you actually give to people, which is like it's a real problem. But once you have this capability, it enables some really, really, really cool flows. Like any user can just delegate permissions to any other user. Like you literally put the rights of the users in the user's hands. They can delegate from their public key to any other public key that they would ever have. They can delegate access to a service. They can delegate their access to their service to another service or to another user. And service providers themselves can delegate access between each other as well. Bearer tokens and like the way that authentication works is so sort of embedded into our skulls a little bit, like we can't get over it, but it's like actually crazy that we just keep around these little secrets and think that they don't leak. Like it's wild. And we use cryptography to make them most of the time, and then we like don't use cryptography to hide the secret, which is what cryptography is for. Like it's wild. But like, with these, we're a service provider. We take people's data. We literally, like, people upload their data. And most of those people are developers because we have a developer API. And so they make an app for users. And they need to give those users permission to upload. But in our original system, we gave them a bearer token, which means that they have to proxy all of the users' uploads through some backend in order just to get into our service. Like it's just dumb. Like it's actually like a bad system. And with UCAN, you can just solve that, right? Like not only does it solve that, but literally like our customers' users' device can just directly upload to our service through this delegation chain. Another thing that it solved is something I've been working on for the better part of like 12 years now, which is open source projects can really do anything, like really anything, except manage a bank account. You cannot manage a bank account. I've tried. I've created entire foundations because open source projects can't manage bank account. It really sucks. So how do we allow open source projects to do more without having to open bank accounts? And the moment that an open source project wants to make a multi-user application, they need a bank account. Like there's going to be a big database of all of that stuff. That's the stack that we live in today. You have to go get a Postgres. Like your Postgres build is going to be big, so you need a bank account. With UCANs, it opens up the possibility of an open source community creating an application and every user showing up with their own data provider, just delegating permission from that data provider to put their data into their account. And because of the way that IPFS linking works and the way that the global addressable network of IPFS works, you just ask the network for a hash and you get back a hash. You get back the data that matches the hash, rather. because of that, we effectively now can create multi-user applications wherever user owns their own data. And the open source project doesn't need to manage a bank account. They don't even store any of the data. They never touch the data. And once we do that, like a lot of applications are going to go away. Like we've been able to make better like Facebooks and Twitters for like a long time. Like it's not. Those apps are not very good. They're just not, right? But the moment that, like, if I were to grab everybody in this room, because this is the skill set to solve this problem, if I were to grab everybody in this room and we went off and we solved that problem, in a year, we would have the same build that a Facebook or a Twitter does if we use the current stack that we have available to us in cloud infrastructure. Now we actually have the tools to just not opt into that problem, which is great. The last thing, once you have these capabilities, right, the obvious thing that you want to do is like you want to use them. You want to like go and call them, right? So in the current ecosystem, there's all these APIs and all of these individual API providers. And one of the things about these API providers is that they all have that relationship with their users like I just talked about. It's just one bearer token to a user and it's one dimensional. It's a flat system where every individual one just talks to itself. With UCAN invocations, the invocation itself ends up getting described in another sort of delegated block. So HTTP, you can pass these over HTTP and do REST calls with them. But the context for the invocation is actually all in that little piece right there. It's all in that little hash-based address. So I can take an invocation API call that I'm going to do, and I can actually hand it to somebody else and give them a hint about where they should send it, and they can invoke that on my behalf. And that's great for us because we specialize in taking your data, and you may have other service providers that do other workloads on that data. So something that you can do is like you can upload some data into our service and then tell us, hey, once that data is available that I'm about to upload to you, go and invoke this token in Vercel to rebuild my app, right? Or rebuild my thing or whatever, right? That's very cool. And we can just use like HTTP and location addressing for that. These are locations, by the way, so we can use location addresses. We're not like immune to HTTP. It's crazy. We can just use simple protocols that work everywhere. It's okay. We don't have to invent another thing that looks like BitTorrent. But yeah, this really allows like an ecosystem not just of like individual users calling each other stuff and connecting to each other, but also service providers talking to each other. Because in the world that we live in, people hire services to do certain jobs. The problem that we want to get out of is like once you pick one, you're locked into them for everything and you can never get your data out and you can never move that API call somewhere else. The moment that you describe your API call in this way with these invocations, it's a protocol. It's something that anybody else could go and implement, and you don't get to make a decision about like, no, you can't implement that. Oracle tried to do that, by the way. They tried to say, no, you can't implement this API, and they lost. So you know that it's true because Oracle's lawyers couldn't even figure it out. So this means that like this huge API landscape, right? All these actors. Right now, they all talk to you, and you manage everything between them. And in this new world of UCAN invocations, all of these providers can talk to each other, and you can pass them invocations to talk to each other. And there's actually a lot, like, before you say like, oh no, they're never gonna do that because they want vendor lock-in, what fucking vendor lock-in? Like, look at how many logos are up here. There's no monopoly power here. Like, everyone should be doing stuff with each other. Nobody has a lock on this stuff at all. So I think that actually, once we have better tools for this, a lot of these people are gonna get on board because it dramatically increases the value of all of these APIs if you can call them inside of these other workflows. And also, you can start to build things that look like very fancy databases that do all kinds of mutations really efficiently. So yeah, like this world that we're talking about really, we've just created two new types of links, right? We have two new types of links. We have DIDs for actors and we have data. And UCANs just glue them together like beautifully. And this is just an update to the web. You can really think of it that way. These are new links that you can use inside of your data and inside of your applications. And inside of your JavaScript applications over HTTP. It's not in conflict with the rest of the stack, but it is a nice little update where when I have data and I don't want to lock it into a particular location, I can solve that problem. And if you solve it with us, we happen to cache all of that in CDNs because when you work with hashed data, it caches very well. And at this point, any actor on the web can make any data that they want on the web accessible to everyone. It's a global network where you can get that data from anybody, and it's portable. And any data on the web can describe any actor on the web, right? Because now we have DIDs, and any location on the web can serve this to any actor because it's hash addressed and because we're using public key cryptography, right? So you're never relying on the fact that I talked to somebody through a location-based address in order to get that information. We've effectively decentralized those workflows on the web without, doing a lot of blockchain-y stuff. And all of these, but at the same time, if you do want to use a blockchain, blockchains are very good at transactions. They really do them well. They're really great at kind of mutating global state. All of these addresses are immutable hashes that you can put into these chains, right? So we've also not centralized ourselves into a blockchain where we can only use that chain. All of these other workloads are somewhere else, and they integrate with other protocols. And all of these interlinked actors provide a means of universal addressability. And that universal addressability of both data and actors and locations and everything else that we have on the web just creates this much bigger, broader web of interlinked data and of API calls that move around that data layer, which is just totally different. And I feel like a future that a lot of us have been building towards but haven't quite gotten to yet. So that's my talk. If you want to try out some of this tech, we did just push out our alpha launch of our new uploader API. So if you want to upload some data, you can upload some data. And that is me. Now I'm going to introduce Carter. Yeah, Brian's already laughing. Yeah, so Brian and I met Carter. It must have been like 11 or 12 years ago. And at the time, Microsoft did a lot of good work on IE. Actually, they came back and they really came proud, and they wanted to show up to the conferences, and so they hired a DevRel person. And this poor DevRel person, me and Joe and Brian would always be like, hey, IE guy, let's go to the bar. But eventually he got a cooler job at Twilio, and we had to use his name as Carter. And in 2011, I ran a conference called NodeConf. And thank you. And the first time I ran that conference in 2011, I really didn't entirely know what I was doing. And Chris Williams, who ran JSConf, reached out to me and said, hey, I ran a conference, I know a lot about this, let's do this together. And so we did the first one together in Portland. And Chris just wanted to help out and wanted the community to grow. And because of his generosity, I ended up helping a lot of other people run their conferences. And Chris ended up helping a lot of people run conferences. And those people ended up helping a lot of other people run conferences. And eventually we had this network of 20 community JavaScript conferences that are all just run by people who love this community. And the thing that really brought the JavaScript community into prominence in by 2015, we were approaching probably 4 or 5 million developers on Node.js. That was all just built on, it wasn't built by any of the money or anything like that. None of the, the corporate interest ebbs and flows and the money comes in and out, but it was really the thing that held it together was just this community of conference organizers and a lot of the people that came there and built all these great open source libraries that we really loved. And we always kind of helped each other out as well. We'd go to each other's conferences and staff it and all that. And Carter was always a really big part of that. And it's just great to see this conference come back because it's something that I really missed in the pandemic. Not just having that network of people that you love, that you can depend on, that will help you out, but also just being in a position to help out other people because you're good at this thing that some people need help with. So yeah, come on up here, Carter, and give it up.